Hello and welcome to this chapter, number system. Number system is a major topic in most aptitude exams. Your familiarity with numbers will not only give you an edge in solving these questions from number system, but overall it helps you in cracking the quant section. Now in this video, I will discuss the types of numbers. We will discuss a few properties of numbers. We will also look at a few important formulas that you could apply to solve questions faster in exams. And most importantly, we will solve some questions to get a deeper understanding of the topic. So let's get started. First, I would like to draw your attention towards the different types of numbers and how they are sort of segregated. So if I look at the overall numbers, right, numbers could be divided into two things, imaginary and real numbers. Now what are imaginary numbers? You think like a root minus 1. Now this is an imaginary number. It is also represented sometimes as I. But for the scope of our discussion today, we are not discussing imaginary numbers. In aptitude exams, most aptitude exams, you will only deal with real numbers and all of this, not really imaginary numbers. Now, all the other numbers are real numbers. That means all your rational numbers plus all irrational numbers makes your real number. Now, what is a rational number? Any number which can be written in the form of p by q, where p and q are your integers. And I'll come to integers again. But anything of the form of p by q, that means if I say 4 upon 3, this is a rational number. If I say 2 is also a rational number because this is 2 by 1, right? So these are all my rational numbers. What are my irrational numbers? If I have pi, right? This is a irrational number. Or if I have, let's say, root 2, this is a irrational number. Now further division of rational numbers could be in integers or fractions. Integers meaning, if let's say you have all the integers are basically like this, let's say from minus infinity to here, let's say you have 0, and then here you have plus infinity. Now these are all your integers. So for example, let's say here you have minus 1, here you have minus 2, here you have minus 3, and so on up till minus infinity. And here you have plus 1, here you have plus 2, plus 3, and so on up till plus infinity. So integers are again, the form is p by q, but again it can divide this one itself evenly. That means 4 by 3 is not an integer because you will get in decimal points, right? 3 into 1 point something, right? 1.33 something. This is not your integer, but 2, your 4, your 6, your 8, your minus 20, all these are your integer values, right? Now 0 is neither a positive nor a negative integer. Just remember this, okay? So from minus infinity to plus infinity, including 0, are your integers. Now what are fractions? Fractions, like I said, all your decimal numbers, right? So for example, if I say any number like 2 by 3, which is not evenly dividing 4 by 5, 7 by 8, all these are your fractions. Further, if I have to segregate integers, you can say all integers are from minus infinity plus infinity including 0. Now whole numbers are, you don't consider negative numbers. You start, so the smallest whole number is 0, then you say 1, 2, 3, 4 up till infinite, right? These are your whole numbers. Your natural numbers start from 1. That means you are excluding 0. 0 is not considered a natural number. You have 1, 2, 3, 4, etc. All this you can write. Now sometimes there are these terminologies that is used. They give questions like these are natural numbers and you have to, certain conditions are given. So it is important for you to familiarize yourself with natural numbers and whole numbers. Now prime numbers is very, very important. You will see a lot of questions on prime numbers. So what are prime numbers? I'm sure all of you are familiar. So any number which has a divisor itself or 1 only is a prime number. For example, what are composite numbers? Something which is not prime is composite. For example, if I look at 12 as a number. Now, is this a prime number or a composite number? It's a composite number. Why? Because what are the different divisors, right? 1 is a divisor for this number. No, 1 is a divisor for all the numbers. So 1 is a divisor, right? What else is a divisor? 2 is a divisor. 2 can evenly divide 2 into 6, 12. 3 can evenly divide 3 into 4, 12. 4 can evenly divide 4 into 3, 12. 6 can evenly divide, right? And of course 12 can divide. So many different divisors or factors are there. However, if you look at prime number like you have your 5, Now what numbers can divide this? 1 and 5 only. You have a number 11, so only 1 or 11 could divide this. Now for example, your prime numbers start from 2. Always remember this. Start from 2, 3, 5, 7, 11 and so on, right? These are all your prime numbers. That means numbers which have divisors only itself and 1 are your prime numbers. All numbers apart from prime numbers would be your composite numbers. So this understanding of different types of numbers is helpful, and we will see this in the questions going forward. Okay, so there's this question. Okay, let's attempt this question. It says, how many prime numbers are there between 1 and 50? Is 1 a prime number? No. Okay, so how will we check this? We already know what are the prime numbers, and we know what are the prime numbers. So prime numbers would start from 2. So let's count how many prime numbers between 1 to 50. Okay, so that means it has to have a divisor only itself and 1. So 2 is that number, 3 is another number, 5 is another number, 7 is another number, 11, 13. Now this you can count, right? 17 is another number. Now after 19 would be 23, another number. Then you have 29, another number. You have 31, another number. You have 37, you have as a number. 41 you have as a number. 43 you have as a number. 47 you have as a number, right? And 48, 49, 50, no. So let's count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That means how many prime numbers are there between 1 to 50? You got 15. So answer is this. Now you had to orally count this and do this, but actually you should already know this. So for example, if you're appearing for any aptitude exam, you should have familiarity with prime numbers. That means from 1 to 100, there are actually a total of 25 prime numbers. This is something we should all know. And 1 to 50, you have 15 prime numbers, which we just calculated, and 51 to 100, you have 10 prime numbers. So this was fairly easy. Let's move to properties of odd and even numbers. So we discussed the different types of numbers. You can also represent the natural numbers into odd numbers and even numbers. So for example, if I say what is even number? Now even number is very simple, and similarly odd number is also very simple. So any number which is evenly divisible by 2. For example, if I say 4, this is an even number. If I say 8, this is an even number, meaning all these are evenly distributed by 2. So for example, if let's say you do 4 by 2, what do you get? 2 into 2, 4. That means you get 2, right? There is no decimals. Similarly here, if I divide 8 by 2, you get directly 4, right? So all your even numbers are starting from, let's say, 2, 4, 6, 8, 10, 12, 14, etc., right? So all these are even numbers. Now what are odd numbers? Which does not evenly divide by 2. That means all the other remaining numbers, that means 1, 3, 5, 7, 9, 11 and so on. Now what we want to know here is what are some of the properties of these numbers, right? So if you look at some of these numbers and look at the properties, so let's first look at, let's say, addition and subtraction. That means if I do some mathematical operations on these numbers, right? So let's do. So if you say, let's say, what would be even plus even? This is always even. This is something we should know. What is odd plus odd? This is always even. Now what is odd plus even? And this is same as even plus odd, which is the same thing. This would always be odd. Now you don't have to remember this, you don't have to by heart that. This is all common sense. That means, see, look at any number, take any number, even plus even. So let's say 2 I take, 2 is a number. Another number, let's say I take, is 4. Now if I am adding 2 even numbers, what is that you're getting? You're getting 6, which is also an even number. That means if you add in any situation, if there's a even plus even number, it will always be even. Similarly odd plus odd, so I'll say, let's say 3 plus 7, right? So how much is this? This is 10. Again, this is what? Even number. This is what we are saying here. Similarly odd plus even, this is also odd, meaning if let's say we have odd, let's say 5 plus even number. Let's say I take 6, this is 11, right? So this is again your odd number. So these are a few properties. Now this is on addition and subtraction. Now let's say if I say multiplication, and let's say I say what is even into even, this would always be even. And you take any number and you do the math, you will see what is odd into odd, this would be odd. Similarly, what is odd into even, this would always be even. And you can see through any number. So for example, if I say even number is 2 and this is, let's say, 8, so how much would this be? 16, this is even. If I say, let's say 7 and this is 11, so 7 into 11, 77, and that is also odd, that means this is correct. Odd, any number, let's say you have 9, even meaning you have, let's say, 8 as even, so 8 into 9, 72, this is again even. So these are a few properties, but sometimes these are helpful properties because there could be questions on that. So let's take a sample example and see if we can do this question. Okay. And interestingly, this is on data sufficiency format. So in this, if you see the directions for questions, it's very important. So there is a question that is asked to you, and what you have to find out is you have to say, can I answer this question, right, on the basis of these two statements? That means this is our sort of hint, right, given to us, hint A, and this is the other hint that is given. And importantly, see the direction. Direction for questions are, you have to mark A, option A, if the question can be answered through statement 1 alone. If you can answer whether P is an even number or no through statement 1 alone, you will mark A. You will mark B if the question can be answered through statement 2 alone. If the question can be answered through either statement, that means either 1 or 2, you mark C. Mark D if the question can be answered by combining both the statements 1 and 2. If only after joining the two statements, information present in hint 1 plus hint 2, statement 1, statement 2, then you can answer, then you can mark D. E if even after combining these two hints, these two statements, we are not able to tell them whether P is an even number or no. Okay, so let's look at our question. It says, is P an even number? We know what are even numbers, right? Anything that is divisible evenly by 2, right? Now it says P is a natural number. Okay, so P, information given about B is P is a natural number. Okay, now natural numbers we know start from 1, so 1, 2, 3 and so on. Value of P such that P is greater than 0, less than 5. Okay, now P is a natural number, that means 0 it's not, okay, and it's less than 5, meaning the value of P, possible values of P could be 1, 2, 3, 4, right? Similarly, now from this, can I say, is P an even number? No. It can be 1, it can be 2, it can be 3, it can be 4. So I don't know, right? It can be anything. Okay, second hint. Let's go to second hint. Forget this information. Okay, now don't make this mistake of going up to the second statement after reading 1 and assuming 1 is already known. So now we will forget all the this information that we got from statement 1. We'll read this alone. It says P is a prime number. If P is a prime number, can you say, is P an even number? No, there are many prime numbers, right? That means it can be 2, it can be 3, it can be 5. So there can be so many prime numbers. So can I say P is an even number? I won't be able to say. I need more information. Now, prime number, okay. So let's say any number, right? It could be 2, 3, 5, 7, 11, whatever, right? Now, so I cannot answer through statement 1 alone, right? I cannot answer through statement B alone. That means these two options are already out, right? And of course can be answered through either statement. Of course this is also out. Now we are left with these two options, right? Mark D or mark E. Now if I join the two statements, it says P possible values are 1, 2, 3, 4, and here it is 2, 3 and so on. Now of course between 1, 2, 3, 4, the only two possible options is 2, 3. That means even after joining these two statements, the value of P could be 2 or 3. So even after joining the two statements, we have two values, right? Can I say is P an even number? I cannot say, because 2 is even, 3 is odd. So that means even after joining the two statements, I cannot say. So I'll mark the option E here. Now, very, very simple, but this is a pure question on, let's say, your numbers, and it used some data sufficiency, format. Okay. Now, also we need to remember a few important formulas, right? So for example, it says sum of n natural numbers. We know natural numbers. First n natural number. This first is important, okay? For example, 1, 2, 3, 4, 5 and so on, right? These are all up till n. So he's saying sum of n natural numbers, that means summation of n, right? This is also known as this. Okay, now they are saying how can you calculate this? So formula for this would be n plus 1 by 2. Now here we could count, but what if this is a big list? So of course we won't be able to, it will take a lot of time. So instead they have given a formula. That means if you are adding the first n natural numbers, and let's say first n, if let's say n is 10, so you can say 10 into 11 upon 2. That means 10 into 11 by 2. That means 11 into 10 by 2 is 5. So 11 into 5, 55, right? So like this. Now sum of squares of first n natural numbers, that means square, 1 square, plus 2 square, plus 3 square, plus 4 square and so on up till n. So n square. All the formula for this one would be summation of n square would be how much? n plus 1, 2n plus 1 by 6, where n here is the value. So it's till 20 or 30, whatever that is. Similarly, sum of cubes of first n natural numbers, this says 1 cube plus 2 cube plus 3 cube plus 4 cube and so on up till n cube. So formula for this would be n plus 1 by 2 ka whole square. That means this was our capital N, right? So isn't it capital N whole square? If capital N is this summation n, right? Sum of first, and you can validate any of those formulas, you can validate, you will get the same answer, right? So for example, if I say sum of first n natural numbers, let's take the first 3, 4 examples. Okay, let's say, okay, 1, 2, 3, 4. Now according to if we do the manual calculation, there will be 4 plus 3, 7 plus 3, 10. That means 10 is the sum, and according to the formula there are 4 numbers. That means it should be 4 into 5 upon 2. So this is 2 into 2, so this is 10, right? So instead of this manual calculation, if we know the formula, we can do it fast. Sum of first n odd numbers, first n odd numbers. Now what is the first odd number? This is your 1, and then 3, and then 5, and then 7, so on. So if let's say these first 4 numbers are given, so he's saying the formula is n square. That means first n odd numbers, so first n numbers meaning first 4 numbers here, right? We have these 4 numbers, that means 4 square, 16 would be the addition. Can we check? 7 plus 5, 12, 12 plus 3, 15 plus 1, 16, that's correct. Sum of first n even numbers meaning 2, 4, 6, 8, 10, etc, etc, right? So sum of all these first n even numbers would be n into n plus 1. Now, okay, so these are a few important formulas that we should remember from the exam perspective. Okay, now let's attempt this final question right before we close this video. So this is a question. It says, if I give you $1 on day 1, okay, if I give you $1 on day 1, that means day 1, if I give you $1, okay, $2 on day 2, okay, on day 2 I am giving you $2, okay, $3 on day 3, okay, on day 3 you are getting $3 and so on. He says how many total number of dollars, okay, how many total number of dollars you will have at the end of the month if the month is January, okay, at the end of the month. Now how many days are there in a month? It could be, I don't know, 28, sometimes 29, it could be 30, 31, but in this case it's given January. If it is given to you Jan, and in Jan we know there are 31 days, right? That means sort of using the calendar plus some other concept. So 31 days are there in calendar. That means up till day 31, right? And day 31, how many dollars you'll get? You'll get $31. So he's saying what would be this total? So instead of doing manually 1, 2, 3, 4 up till 31, which will take a long time, this is very simple. If you remember the formula that we have just done, this is summation n, right? And summation n, this is how much? n plus 1 upon 2, right? This is the formula that was there in the previous table. That means summation n. Now summation n is how much here? 31. That means how much would this be? This would be 31 into n plus 1. That means this would be 32 upon 2. So this would be 31 into 16. If you do the math, you can do this, right? So this is very easy. This is 31 into 16. 6 into 1, 6, 6, 3, 18. and here you do 31, so all you get is 694. So how much money would you have at the end of it? Would be $496. So what is the correct option? C. Now again, this used the application of the previous formula which we learned here, sum of n natural number, first n natural numbers. So we come to an end of this video, but I hope you got an understanding of the different types of numbers, you understood prime numbers, you got some familiarity with numbers, but I would urge you to practice as many questions as you can on numbers so that you're more comfortable with these numbers. So I look forward to seeing you in the next video where we'll cover more concepts and more questions on number system.